Welcome back to the Jörn YouTube channel. Thank you very much for watching us. And today's topic is continuing our story about lightweight design. Well, just one point in advance I would like to mention. We are very successful with our lightweight concept. We've already won 3 projects where we are now working on to get real parts in serious production. Enjoy the video. Good. Lightweight design part 2, so to speak. First, I want to give you an update about our activities regarding the spherical joint issues. I mean, last time I presented some measurement data, some brief FEA calculations, and some pre-testing. In the meantime, we have performed more and more detailed FEA calculations, and even more important, we've performed the durability lifetime test in order to compare the classical design, the heavy design, with the lightweight design. And I can tell you on this point that we achieved very comparable results. So the lightweight design, just to summarize, reaches the same mechanical behavior in terms of stiffness, in terms of connectivity anyway, and in terms of durability. So we believe it's a very good results of our activities. So far, we have not found any hurdles for introducing this concept. So we're very happy with that. Today, I want to continue to talk about further activities. We have applied this technology to a new group of products, to slit bushes. I have prepared a slit bush here. Oops, sorry. Here you see the slit bush. That's the typical slit. That's a bush with a pin, with a metal pin. If you want to learn more about slit bushes, I refer to our videos regarding slit bushes, where you can see how a slit bush works in detail. This bush is containing of a pin, of a solid pin, and cylindrical parts in the middle. So we did the same what we did for the spherical joints. We just replaced some heavyweight steel material by plastic. With this part, we achieved a weight drop by around 850 grams, which is again more or less a third of the overall weight of the original part. So that's pretty nice, I think. That's a pretty good achievement. And of course, we've performed all the FEA calculation as well. So how did we do that? I would just put that away, because even it's light, it's still heavy after a while. Okay, well, how we do that? How are we going to do that? I mean, you can see here the pin, how it looks like. It's a very cubical design, and it looks a little bit strange with these 2 rails there, with the 2 nuts in the notches there on the side, but very smooth notches, not very sharp notches, so not critical. And it's made by flat steel. It's made with a very minimum of machining. And next step is we have 2 half shells made of plastic, and then we move them together, we assemble that, we mount that together and get one cylindrical overall pin. So this pin then will be taken and put into the vulcanization tool, and we do the vulcanization process as it would be very normal with a classical pure metal pin design. So, and then it looks from the outside, it looks like a very normal slit bush. So you can't, from this perspective, you can't distinguish this lightweight design. I mean, you could if you would hold it in your hand, but just optically, you can't distinguish this one from the classical heavy design. And of course, to get a little bit more idea about the details, we've just cut off one edge so that you can have a look inside. And of course, Our spherical lightweight design part was built by the same way, so we have another cut of this part here. So what's the trick with the flat cubical pin? The trick, the idea is to use a flat steel material which is drawn in advance and then very cheap. So it's produced with the final tolerances, with the final dimensions, and we just have to machine the two holes and machine the notches. Talking about the notches, I mean actually the notches is the main difference of this pin design to a classical pin design. I mean, taking a normal slit bush with a solid pin like this one here, you see a sharp notch here in this area, in this edge. Can you see that? And if the pin cracks in operation, it will start here or there. Yeah, and this is the big plus, the big advantage of the new design, because we've just taken out these kind of notches. So if you don't have a notch, you don't have very high tension due to the notch. That's logical, right? And therefore, even if you have the same level of mechanical tension in that area, in the same area, it would be significantly less critical because you don't have the notch. And that gives you the opportunity to downgrade the steel material for that pin. I mean, you don't need to have a very, very high level, very, very expensive steel. You could use a more or less normal steel, yeah? And that's enough, that's robust enough. That's all. So summarizing that means we have a lightweight design where we can save around 33% of the overall weight, which is quite significant. Of that part, we produce around 100 units a year, and saving 800 grams per piece means an overall weight saving of 80 tons steel a year. 80 tons of steel which don't need to be moved. That's a significant saving in terms of CO2 emissions. You get that with the same functionality and at a very, very attractive cost, okay? Because the way it's built, it's very simple. Of course, I should not forget to mention that we applied for a patent as well, according to this idea. Yeah, well, as I've said before, we've been very successful with our lightweight design part 1. Many people have seen our video. Thank you for all our watchers, spectators. Many people have seen and read our posts in the social media, such as LinkedIn or Instagram or so far. So thank you very much for watching. But which is at the end of the day most important for us is that we've won the opportunity to work on 3 different projects with 3 different big customers for us. So if you want to become number 4, speed up, because sooner or later our capacity will be fully booked. Yeah? So you be faster than that. That's it about lightweight design for today. I would not forget to say thank you very much to my colleague Michael Schiebel behind the camera, and later he will do all the cutting at the cutting desk to cut off my mistakes, my errors I've made. And if you liked what you've seen, please leave us a like. Please subscribe for the channel. And if you want to learn more about the lightweight design or contact us, use all the contact information which are mentioned down in the info box, or send us an email using the email address lightweightdesign@jörn-GmbH.com. Thank you very much. Bye bye. See you next time.